Deadline looming? Cramming for exams? Or just something you don't want to do? You need procrastination. Procrastination's been especially formulated to give the sense of time flashing by without effort or discipline or concerted action.
Hello YouTube, it's been a while. My friend Mark from Rotary SMP just explained why you haven't seen a video from me over 6 months. I've been busy procrastinating. Okay, not just procrastinating. The first version of this idea had a fatal flaw, and apparently my ego needed 6 months to process that. 2 years ago I built this low profile way cover from a reinforced Teflon sheet with a simple spring mechanism to retract it. It worked, kind of, but not the way I imagined it. So today we're fixing it properly. After almost 2 years of actually using it, I discovered that in some condition it has a flaw that we're trying to address today. In the regular LinuxCNC, you can start the spindle in constant surface speed mode only when running a program. However, in my custom LinuxCNC controller, I've managed to do a workaround so that I also have this feature when working in manual mode. Even though what rolls back this sheet is a constant force spring, the pulling force across all its length does not seem constant at all. With fine chips, at the end of the travel, the chip buildup in the wiper overwhelms the spring, and the cover buckles up. I had a feeling this might become a problem when I first built it, but since it was just a prototype, I wanted to see how the Teflon sheet would behave on the long run. Now that it passed the test of fire, let's take it off and see how we can tackle this issue. Back when I was filming with my iPhone, capturing overhead shots was anything but easy. Fortunately, through YouTube, I met some great people, and one of them, featured later in this video, helped me significantly with the setup you're seeing here. Over time, I learned that filming has to stay secondary to the actual work. If a camera gets in the way, or if I have to watch what I'm doing through a screen, I will avoid that setup, even if it means missing a lot of assembly and disassembly footage. But no matter how carefully you plan things, there is always something unexpected waiting to happen. Like this thunderstorm alert. Oh boy. Let's continue with the disassembly. This is the spring that pulls back the Teflon sheet. Seeing how out of position it is makes me think that I could have 3D printed some guidance system so that it doesn't drift that bad. Even though it looks simple now, when I first designed this, it took me some time to figure out how to attach the spring to the shaft. Hopefully, this gives others a useful idea. As I was finishing the disassembly, the forecasted storm turned to be just a calm, relaxing rain. And with the threshold installed, it's pure ASMR now. But it wasn't always like that. I've shown you how bad it used to be in part 1 of my Weiler rebuild video. In the video I've built the way cover, this was the second, more advanced version of the pulling mechanism. Let's get some materials and start building it. Over 80% of the aluminum in this drawer came at no cost. The supplier I buy aluminum from had a big box of cut-offs and I could grab whatever I needed. The downside? Excepting these pieces which are 70-75 aluminum, I don't know what types other are. But for hobby prototyping projects without rigid material specifications, these are perfect. The bandsaw and the surface grinder next to it are crying out for a flood coolant system, but the planets haven't yet fully aligned to make that happen. And now comes the part that I dislike the most on every project, squaring the stock. Fortunately, this chunk has two parallel faces that are exactly to size, so I don't need to machine those. At least when I'm working on one-off projects, I tend to do the stock squaring in manual mode. I don't have any formal training in machining or experience with professional CNC controllers, so let me know in the comments what's your favorite way of squaring a stock on a CNC machine. Before we run the first program, let's tell the machine where the stock is in the 3D space. About 5 years ago, I wrote this custom UI on top of LinuxCNC because I had some fantasies in getting to look and behave the way I wanted. One of the behaviors I wanted to have was to start a probing routine with a cycle start and not with a touch of a button on a screen. I've managed to do what I wanted, but now looking back, I don't think I would be willing to do all that effort again. Because of a few technical limitations, the horizontal part of the camera arm sits right at the forehead level, so this is the kind of gymnastics I have to do, and when I forget it's there, I get a painful reminder. This is what I came up with in my attempt to measure a tool using as few clicks as possible. Since I don't have enough tool holders to maintain a consistent tool library in Fusion and in the controller, I end up changing them for every job. Once I load the exported program from the Dropbox folder, we're ready to go. So far, capturing multiple angles of what I was doing has been quite difficult, especially when I was in the front of the camera and I couldn't see what it was actually framing. The new setup with the camera monitor completely solves that. These edges need some chamfers. I've discovered that even if I use the right tool, they came out nicer if I have the proper outfit. This is my way of honoring the man who inspired me on this channel. The conclusion is that the outfit really made a difference. The first setup is complete, 2 more to go. For wrapping this 7075 aluminum stock, I will use this 10mm end mill 3-flute uncoated carbide from Fresa. Upon some previous experiences, it seems to work surprisingly good with my mist coolant system. A comment that kept coming up on other videos was to avoid music and keep their own machining sounds, because for machinists, that's better than any soundtrack. So I thought, why bother with copyrighted music when I can just let you enjoy this instead? We can't call this side complete without some chamfers. Because chamfers are what separates us from the animals. We're done with this side of the album, so let's clamp the other side and hear the rest of the song. I hope this matched your taste in music. The surface quality is far from a mirror finish. The head of my machine is out of tram and trimming it isn't quite a low-hanging fruit. But seeing that the finish isn't as nice as I hoped is starting to bother me. The timing belt housing we've just made will be mounted onto the existing way cover housing. But to do that, we need to add a few threaded holes and a pocket to allow the timing belt to pass through. In general, I don't enjoy machining aluminum, because without flat coolant or at least with a generous amount of mist, it tends to stick to the tool. But machining 7075 aluminum, it's a real pleasure. It doesn't stick and I can really push the feed rates. Okay, let's take a break from the milling work and do some lathe work. Now, I see it's 6082 and not 7075 as I said initially. The final OD of this part needs to be 50mm, but I have just a few tenths of a millimeter extra stock. Yep, it didn't quite cleaned up yet. But fortunately I still have 0.15mm to go. In prototyping, the manual versus CNC debates never really ends. But why choose when you can have the best of both worlds? I get the one-off speed advantage of a manual lathe while still having constant surface speed, just like a CNC. And with the proper outfit and a few joystick moves, I can cut chamfers just as clean as on a CNC. This feature existed in the old controller before it died, and I found it useful enough to spend a fair amount of time bringing it over to LinuxCNC. With the conversational that I wrote, I could also drill using the carriage, but I don't have the proper tool holder yet. So, for run-off operations like this, I'm more comfortable doing it with the tailstock. With the lathe in first gear, the controller limits the speed range to 700 RPM. For drilling, we'll run at 300 RPM. With a 22mm hole already there, opening it to 35mm, it's a boring bar job. Over 90% of my tools came from flea markets or sites like Craigslist or Facebook Marketplace, this carbide boring bar included. By activating the taper turning, we can also cut inside chamfers just by moving the joystick towards Z- or Z+. Hopefully that wasn't that boring. The last feature we need on this side is a groove for the retaining ring, and this Iscar Pico is just the right tool for the job. The retaining ring fits perfectly, so we can move on and part it off. On my previous Wabico lathe, parting off was almost impossible. But on a rigid machine like this one, even parting stainless feels incredibly easy. We need to finish the other side, so clamping with a sheet of paper will make sure that I'm not leaving any dents. But since doing anything on camera takes 4 to 5 times longer than usual, it was already afternoon and I was already hungry. So it was time for a well-deserved lunch. Aici era bun unghiul.
Asta, vedem. Nu este important.
Am călit o ceapă de mare. Când a fost aia călit am pus 6 ouă peste ea. 2 avocado, jumătate de fasole, jumătate de linte, jumătate de năut, jumătate de roșie, salată.
Chestia asta chiar îți dă energie când n-ai cumpărat.
Now that I've tamed the hunger monster, it's time to swap the vice jaws for what's next. With these jaws, I can clamp a 3-jaw chuck so I can securely hold any round stock. Keeping this 3-jaw chuck in that drawer feels a bit too far from the mill for my taste. But I've got a plan to make the shop even more space efficient, so stay tuned for an upcoming shop tour video. After half an hour of looking for the 8mm squared chuck key, I settled for an emergency solution, the shank of a brace tip boring bar. By the time the shop tour video comes out, the organization will be much better, so this should not happen again. I forgot to press the record button during the first milling operation, but spoiler alert, we'll get another chance to film it. Nu cred. Bă, măta s-o fut astăzi, dar ce p***a mea ai? Oh, băga mea și p***a măta. De ce? So, we've got a broken 2.5mm drill snapped off flush with the surface, with no chance of getting it out. At that point, my perfectionist side had to make peace with the practical one, so I adapted the design to be 1.2mm shorter and live with the 2.5mm drill buried inside this part. I would rather risk chipping the insert edge when it hits the broken HSS than remake the entire part. You can tell by the sound that the insert got chipped, but other than a superficial scratch where the drill sticked out, it cleared out nice. After breaking the sharp edges, we have another chance to get this right. This time I went with smaller packs and full retracts to make sure that the chips don't clog up the flutes. And I got away with it. The part we just finished has a 35mm ID which needs another element within it. An eccentric bushing that will allow us to tension the driving belt. And this aluminum stock, even though it's quite close as size, might be a good candidate for it. The stock is only 0.1mm larger than the bore, but hopefully there's enough meat to clean up the surface. And yes, it cleaned up nicely and the fit is what I expected. So let's part it off. But not before a very precise length measurement. In a shop as small as mine, making use of even the smallest spaces for storage is almost mandatory. These turn out to be the perfect spot for storing unused chucks. And because the fit between these two surfaces is so good, I cannot afford to dent it. So let's do this by the book and add some copper shims. I swapped the chucks because I needed to offset the center of the hole by 1.25 mm, which gives me a 2.5 mm adjustment range between the pulley centers. I've never been particularly fast at dialing a 4-jaw chuck, but after a few minutes I got it where I wanted. The 22mm bearing is such a nice fit that I almost couldn't get it back out. Time to cut the retaining ring groove. And another chuck swap, because no part is complete without a proper chamfer. Before assembling these parts, we just need to take care of a few details. Since the part we've just made will rotate inside this housing, we need a way to lock it in place. An M6 screw should do the job. Next, we need to add a way to rotate the inner drum to tension the belt. I'll be using the circle clip pliers for that, so we need to add 2 holes. Let's do a preliminary assembly so that we can transfer the position of the set screw onto the inner part. Once we have the location, cutting a groove there will make sure that any marks left by the set screw won't interfere with the rotation. We're just a few parts away from assembling everything. This piece will serve as a spacer between the 2 bearings. And this is how I set the Z0 for the parting tool. To transmit the rotation from the input shaft to the shaft that rolls the Teflon sheet, we'll use these HTD3 pulleys, which need a bit of preparation. And we're ready. Here are all the parts that we need. Let's turn all this into a single assembly. The sheet is under tension and constantly trying to unwind. The cordless drill says, no. As I was winding the Teflon sheet, a doubt started creeping in about why this solution might not actually work. I talked it through with a few people and none of them had any objection on my approach. But hopefully this is just a temporary paranoid episode, so let's continue with the assembly. I had a few ideas on how to tension the belt, but the most elegant solution, at least to me, was this eccentric bushing. I'd be interested to hear what your approach would be and the reason behind it. Since I'm a master procrastinator, getting this back installed feels like a small victory. The way I imagined this working was to have a timing belt wrapped around this pulley, with that belt attached to the apron, so moving the apron would wind and unwind the Teflon sheet proportionally in either direction. Now, while editing, I realized that proportional was the keyword here. But hold that thought until I finish mounting the temporary 3D printed idler pulley and put the timing belt on. The purpose of this spring was to accommodate the changing diameter of the Teflon roll sheet as it winds and unwinds.
It was at this moment that he knew. He fucked up.
For some of you, it was probably obvious this would not work from the moment you saw the concept. For me, it only became clear after I built everything and tested it. As the roll diameter increases, the shaft will need to spin progressively slower to keep the same linear speed, So attaching the bell to the moving apron simply won't work. I guess I got used to the idea that mistakes are something you hide. That if you fail at something that matters, somehow you are a failure. So when this didn't work, I kinda lost all the motivation to even edit the video. It started great and then ended up as a fail. Which is funny because failure is literally part of engineering. And maybe Life Factory Made kinda forced me to chase perfection a bit too much. However, let's see how we can actually make this work. Option 1. I could build a bigger housing, add a stronger spring. Simple, kinda crude, and honestly a bit boring. So naturally, my mind started over-engineering it. One of my viewers suggested something much more interesting. Using a DC servo motor as an electronic spring. A torque control motor could pull harder in one direction and softer in the other, basically behaving like a programmable spring. A while ago, I saw a video from Technic ClearPath where they presented one of their features of their MSVC models. Their follow digital torque command is exactly what I needed for my use case. Unfortunately, with the power supply and cables, they're not exactly cheap for a hobby project like mine. But if someone from Technic is watching, I promise this will become the most ridiculously over-engineered way cover you've ever seen. So, let's see where this goes next. Talking about failures. I've been recording this outro for the last 3 hours. How about that? For some of you, it was probably obvious. For some of you, it was probably obvious. For some of you, it was probably obvious that this wouldn't work. The chef would need to spin progressively, maybe chase perfection, maybe, which is funny because failurely had a stronger spring, and that's simple. No, mai pot, mă, nu mi-am epuizat.